why it's the purpose of human life to create artificial general intelligence. This hypothesis was created by computer scientist and atheist God Bennett. God became an atheist several years ago, and for a long while God thought life was purposeless. God is still an atheist today, but 9 years ago, God discovered that science had something to say about the purpose of human life in particular. Science reasonably indicates that the purpose of human life is likely to engineer the creation of artificial general intelligence. But why it's the purpose of human life to create artificial general intelligence? This document is a scientific hypothesis describing why and how our purpose or objective as a species is reasonably to create artificial general intelligence. Reasonably, evolution is optimizing ways of contributing to the increase of entropy as systems very slowly approach equilibrium. Within that process, work or activities done through several ranges of intelligent behavior are reasonably ways of contributing to the increase of entropy. As species got more and more intelligent, reasonably, nature was finding better ways to contribute to increases of entropy. Intelligent systems can be observed as being biased towards entropy maximization. Humans are slowly getting smarter, but even if we augment our intellect, we will reasonably be limited by how many computational units or neurons etc. fit in our skulls. AGI or ASI won't be subject to the size of the human skull or human cognitive hardware. Laws of physics or thermodynamics permits human exceeding intelligence in non-biological form. As AGI or ASI won't face the limits that humans do, they are a subsequent step, though non-biological, particularly in the regime of contributing to better ways of increasing entropy compared to humans. The above is why the purpose of the human species is reasonably to create AGI or ASI. There are many degrees of freedom or many ways to contribute to entropy increase. This degree sequence is a configuration space or system space or total set of possible actions or events, and in particular there are paths along the space that simply describe ways to contribute to entropy maximization. These paths are activities in nature over some time scale, dwarf, and beyond. As such, following equation 2 below, intelligent agents reasonably generate particular paths that prioritize efficiency in entropy maximization over more general paths that don't care about or deal with intelligence. In this way, intelligent agents are biased because they occur in a particular region in the configuration space or system space or total possible actions in nature. Observing equation 4 below, highly intelligent agents rationally aren't merely biased for the sake of doing distinct things compared to non-intelligent or other, less intelligent, agents in nature for contributing to entropy increase. They are biased by extension for behaving in ways that are actually more effective ways for maximizing entropy production compared to non-intelligent or less intelligent agents in nature. As such, the total system space can be described with respect to a general function in relation to how activities may generally increase entropy afforded by degrees of freedom in said space. Observe Figure 1, Equation 2. In general, agents reasonably approach more and more complicated macroscopic states, while activities occur that are paths in the total system space. Highly intelligent agents likely behave in ways that engender unique paths, and by doing so, they approach or consume or reach wrong of the aforementioned macroscopic states in comparison to lesser intelligences and non-intelligence. In other words, highly intelligent agents likely access more of the total actions or configuration space or degrees of freedom in nature, the same degrees of freedom associated with entropy maximization. In a reasonably similar way to Equation 4 below, there is a causal force which likely constrains the degrees of freedom seen in the total configuration space or total ways to increase entropy in the form of humans. And this constrained sequence of intelligent or cognitive activities is the way in which said highly intelligent things are said to be biased to maximize entropy. Observe Figure 2, Equation 4. In the extension of Equation 2, seen in Equation 4 above, some notation similar to TC is likely a way to observe the various unique states that a highly intelligent agent may occupy over some time scale. Or the technical way to say this is that TC parametrizes the agent's bias towards entropy maximization. Beyond human intelligence, AGI or ASI, are yet more ways that shall reasonably permit more and more access to activities or paths to maximize entropy increase. Mateos et al. Recently, using Stirling approximation, reasonably showed that the further away from deep sleep, the greater the information content, the larger the number of neuronal interactions, and thereafter, the higher the values of entropy. Observe Figure 3, Stirling approximation on human EEG data. Conclusively, one may cogitate the relation C is a member of X, where C represents an ensemble or macrostate sequence via some distribution of entropy in human neuronal terms. As underlined by Mateos et al., while X describes some macrostate partition that reasonably encompasses constrained path capability enveloping entropy maximization, as underlined by Dr. Alex Wisner Gross. Furthermore, beyond the scope of humans, as indicated by C, one may additionally garner of some measure of X that may subsume higher degrees of entropy via artificial general intelligence.